Hello class, this is a continuation on scale drawing and ratios. In this video, we'll be applying our concepts of scale and ratio to a more real-world problem. So here we go. So here we have a building plan or a floor plan. And as you can see, we have a scale here in our bottom left. And remember, almost all scale drawings will be given one here, unless it's part of the problem to find the scale. Part A of this question is we're going to measure the dimensions of the following room and then calculate the area of the room. Okay, so here we have, it says here, the rumpus room. So I'll demonstrate to you first here. When it says to measure, it literally means we're going to be grabbing a ruler. Got a very unique ruler here. It actually, it gives a to scale, hopefully, measurement of once this is printed out. And we're going to measure from the inside of the room, so inside of the pink wall. So from there, we can see that this length here along the bottom on the rumpus room, that there is measuring about 2.3 centimeters. Okay, so we know the rumpus room is 2.3 centimeters by, let's rotate this. And I'm just going to assume that this is a perfect square. I'm not going to count this part here. So for this, let's measure it. My 0 is here. So bring that 0, and it's going to be the inside of the room. There we have it. So we're going to go from 0 all the way down here. So that there I can see is going to be that 0, 1, 2, 2.5 is there, 2.6, 7, and 8. So approximately 2.8 centimeters. 2.8 centimeters. Well, for this, now it's just a matter of applying our scale to each of these measurements. So let's call this its length and its width, whichever you want to call it. So now let's find the real length and the real width of this room. So it is going to be 1 is to 200. And remember, the one on the left is our map drawing or scale drawing. So 2.3 centimeters. Multiplying that by 200, because remember, we look at from 1 to become 2.3. That's times 2.3. So 200 times 2.3. That gets us 460 centimeters. We do the exact same thing for this measurement. So it's going to be, again, map, real, and the measurement that we have is 2.8 centimeters. So multiplying 200 by 2.8, we get 560 centimeters. I'm going to convert these into meters because that's a more realistic measurement for rooms in the real world. So this is 4.6 meters and 5.6 meters. Now to really drill in our understanding, we've just measured the length and its width, 2.3 by 2.8. So on our drawing, these are the scale lengths, but by applying our scale, the real lengths of these are 4.6 and 5.6 meters. And now to calculate the area, it's just simply A equals 4.6 times 5.6. And that's just now 4.6 by 5.6. This gets us 25.76 meter squared. And there we have it. Now that we have this, it's just a matter of repeating it again. You can pause and give it a go yourself for bedroom 2. Okay, so let's do this now. For bedroom 2, let's grab a ruler. And obviously your measurements might be slightly different to ours and to mine. That there looks to me exactly about 2 centimeters. So it's 2. Oh, did I ask for bedroom 2? Yes, bedroom 2. So 2 centimeters. That's 2. Let's calculate its height or width, whatever we want to call it. Mhm. Oops, whoopsie daisy. Bring that back. That there, we get that to be about 1 centimeter. And that looks to be, oops, it's not a 0, sorry. That's 1 centimeter, 1.567, 1.7. It looks to be 1.7. So 2 by 1.7. So 2 centimeters by 1.7 centimeters. Now it's just, again, a matter of applying our scale. So this is the, sorry, applying the scale. And as we've seen, it's just a matter of multiplying 200 by the measurement that we got. So multiplying by 200, this gets us 400 centimeters by 1.7 times 200. That gets us 340, oops, 340 centimeters, which in meters is 4 by 3.4. And so the area is simply 4 times 3.4, 3.4. That gets us 13.6 meter squared. Let's do a final example here. The living room. Okay, the hardest part here, as you've seen, is just getting the ruler and the measurement. So for this one, from the inside, it looks to be very close to 2 centimeters. Let's just use that. That there looks to be about 2 centimeters. And bring that on 0. Going along vertically here now, it's going to be, what's that? That's 2.5, 6, and 7. 2.7 I'm getting. So let's just go with that. 2.7 centimeters going along vertically. So that is 2 centimeters by 2.7 centimeters. Okay, and then now applying our scale, and I'll do this the long way again. Our scale was 1 is to 200, and we want to make this 2 centimeters. So for 1 to become 2, we've multiplied by 2. So we multiply this side by 2 as well. So this becomes 400 centimeters. And likewise with this, our scale was 1 is to 1 is to 200. And it has now become 2.7 centimeters. So we are multiplying 200 by 2.7. That gets us 540 centimeters. And in meters now, so this is by 540 centimeters, which now as an area we can calculate that is 4 meters by 5.4 meters. So 4 times 5.4. That gets us, plus times 21.6 meter squared. Right, so I hope that's giving you an insight into how we can apply this to a real world example where we have to do some measurements. I'll see you in the next video for this example where we again, work backwards, where we are given the real distance. And so we're going to find what the, excuse me, what the scale distance would be. Hope to see you in the next video, and best of luck.